Okay, so let's start coding. First of all, if anybody's going to follow me on Twitter, don't do it yet, because I need to launch this kind of like cool new stack thing. So this is a serverless CloudFormation project. You're going to see all of my credentials now. It's OK. I delete them after every demo. And normally this is all set up and ready to go, but I had to reboot. So we're just going to paste in all these secrets, all these passwords, take your pictures now. And we're going to bump this up to like 100 so that we can do this very quickly. And then I acknowledge that AWS is going to bill me, except they won't because I work there. By the way, work at AWS. You don't have to pay your AWS bill. Good problem to have. OK, so what I've just done is I've spun up this Twitter autoresponder stack. And it's a serverless platform that basically, whenever I get a new follower on Twitter, triggered by the new Twitter webhooks API, which is pretty baller. You should check it out. And you can go at Andy Pipes, and you can tell him I told you can do that to get your whitelist request approved faster. Great plan. He's going to hate me. So this is just going to create some things, and you can see the Cloud Stack provisioning process and all that good stuff. It's going to create some roles, create a DDB table, and then if you follow me on Twitter, you're going to get a nice new message. It'll be fun, because I like spamming people. So we're going to minimize all my credentials now. We launch this. We've got this other thing. Does it have any items in it? OK. And then the next thing that I need to do is, being a millennial, I take a lot of selfies. So I want to can you guys see anything I'm doing right now? OK. So I want to start syncing all of those selfies to the cloud. I'm probably the first person to SSH into a server at a serverless conference. Is that true? Yeah? OK. The reason I'm doing that is that I know all of you guys like your Wi-Fi, and I don't want to slam your Wi-Fi when I'm uploading my 10,000 selfies, so I'm doing it from EC2. So we're going to go into the selfies folder, and then we're going to like sync. And this is me, a bunch of selfies of me growing a beard, and it's like my laptop webcam taking a picture every like hour over the past, I don't know, 5 years. So we're going to start that. Nope, we're not. Sorry. So we're going to go to this demo. We're going to make sure tracing is turned on. We're going to make sure the triggers are all good. Nope, they're not. So we're going to go S3. We're going to add in a trigger, which is going to be beards. Is that what I called it? Yeah, that seems right. And then we're going to say object created. Zoom in on my console. Make it bigger. Like that. Web console. Better? Thank you. OK, so we've added this trigger. And then the other thing we need to do is make sure the tables are all set up. And I can show you the code for this here. So essentially what this is doing, can I make this bigger? This is in Java, which is a great language, unlike JavaScript. How many enemies did I just make? A lot? All right. I believe that JavaScript is just mass psychosis. So, and we all participate in it. So, OK. So basically all this is doing is it's creating a recognition client. Who here has heard of recognition before? Recognition is a really, really awesome, somewhat creepy new service that detects labels and emotions and other things in faces. So what this is doing is it's creating a detect labels request on each image. And then it's saying if the confidence is over 70, include that in my result set. And then I want you to go and build a little map with it. And then I want you to put all of those things into DynamoDB. And then return a completely useless return parameter. But I needed to return something, so I did. And that's going to be running over the next little bit. But first, I have to go into S3 and make sure my bucket has the permissions. And you know what? We will just make it any authenticated AWS user. So good luck. If you guys remember the name of the thing, you can mess around with my demo. Am I allowed to say fuck? All right. Did Charity Major speak today? Yeah. OK, sweet. Fucking awesome. Let's go. All right. Cool. So the other thing that we're going to talk about, this is not the right one, herpderp.py allows you to log in over Twitch into the AWS console. So you can go to this URL, Twitch. And you can use your Twitch credentials to log into an AWS account, and your permissions are granted for 15 minutes, and you have the remaining, oops, I don't want to log out, so I'm not going to demo it, to figure out how to elevate your privilege. And this is a contest that's been running on Twitch for the past few days. So we live stream on Twitch, twitch.tv/AWS. If you ever wanted to prove that you were a real hacker with real skills, you can try and see if you can get in. We're going to close out all of this stuff now. And I think we can go to the presentation. So those are all my demos that I needed to get started, just because they're going to run while I'm talking. And let's go. Let's do an actual slideshow like a real professional. OK, so I do not remember the abstract that I submitted for this talk. So I don't know if you guys read it or not. But basically what we're going to talk about are really fun things. We already took our selfie. This is me. I'm a technical evangelist at AWS, which means if you ever have any problems with anything, you should just ping me and yell at me. I'm the perfect person to receive your wrath and also your praise, but that never happens. So before I worked at Amazon, I worked at SpaceX, and before that, I worked at NASA. NASA is a wonderful organization that's underfunded and incredibly bureaucratic and slow. SpaceX is a wonderful corporation that you have to work 100-hour work weeks. All of these are fun things to do. I'm really obsessed with space. These slides are not just mine. Many people from AWS have contributed to these, and I wanted to thank all of them. If any of you are in the audience and you helped build these, thank you so much. And since you guys have been to a lot of presentations already, we're not going to talk about what the hell AWS Lambda is or what a serverless application is. We're just going to forget all of that stuff. And JavaScript is terrible. I'm kidding. So what is AWS Lambda? Is this being recorded? I hope not. Oh, shit. So what is AWS Lambda? It doesn't matter. What are serverless applications? It sort of matters. So this is an architecture diagram, which is how most people spend their time in PowerPoint. And essentially, the way that I think of a serverless application is that you have a bunch of stuff that needs to do things, business things. And you can front that with CloudFront. You can have it go into API Gateway, and you can monitor it all with CloudWatch. And you can have like this API Gateway cache, which is just memcached. And then you have your API Gateway go and proxy out to other things that you're talking to or to some AWS service. You can actually, directly from API Gateway, use the base64 encoding and the velocity templates, the body map, to send stuff directly into Kinesis, which is pretty damn cool, in my opinion. So you don't even need a Lambda function to put stuff into Kinesis. You can just have API Gateway do that for you. Then you can talk to other AWS endpoints, and then Lambda functions. And Lambda functions are what most people think about when they think about serverless. So that's what a serverless application is. That's not at all what we're going to build today. So I want to talk about some unexpected adventures in Lambda and AWS. I have the distinct pleasure of going around the world and meeting thousands and thousands of AWS customers all the time. And the stuff that you guys are building is just so freaking awesome. And I get really jazzed about it, and I'm emphatic. And there's a really great picture of me on the internet. If you Google evangelism, it's like the first result, and it's like me yelling and screaming, holding a beer in my hand, like, that's so cool. But essentially, when you're trying to think outside of the box, when you're trying to think about really cool stuff that you can build, you have to think about your building blocks. And I think that AWS Lambda is a little bit like Legos. I mean, programming as a whole is a little bit like Legos. And these are the building blocks that we have. We have S3, we have our data stores, we have these config repos, and we have kind of like the CI/CD pipeline. Chris Munn's probably talked about that earlier. And then we have kind of these event services, we have these endpoints. And the endpoints are where things get interesting, because the endpoints are not just the things that you're sending stuff out to, it's also the place where you're bringing stuff in. And I think the endpoints are where people focus too narrowly. And I wanted to show you that you can be extremely creative with your Lambda functions and build some extremely terrifying things. Like, you can do anything. And I think a lot of the time, oh, sorry. There's no audio. Is the audio working? Damn. Come on, guys. Audio's up through HDMI, or? OK. OK. Oh, shit, my mom's calling.
Hi, Randall. This is Mom. I need to know where you are right away. Thank you.
Oh, crap. So essentially, I travel around the world, which is an amazing gig. Unfortunately, I'm always in a different place. And relatives and friends, and my mother primarily, generate thousands of requests per second about my current location. And those requests are typically in JSON. So when I need to iterate quickly, the first thing that I need to do is I need to focus on the business logic. I have a business goal in mind. The code, the technology that I use to get there doesn't matter. What I need to do is I need to think about how I can solve my problem, and then the code is kind of secondary. And this is only when I need to iterate quickly. So I need to reuse stuff I already have. I need to hack it together. I need to be able to test locally very quickly. And I also need to be able to test remotely very quickly. So my unit test and my integration test have to be working super fast. And then I need to be able to scale as your mother generates more and more requests. So focusing on the business logic, we have the mother. That's kind of our client. That's our requester. Then we have the information, which is in this case, are you alive? When was your last bowel movement? Are you surviving? And the mother generates a JSON query into the information store, and then we send back a JSON response. And then the child is the one putting the location information among various other bodily functions into the information store. And that's really just a Lambda function. Maybe it's talking out to DynamoDB or something, but it's fairly trivial to say our information store in this case is a Lambda function. But rather than putting it into the Lambda function, I find it much more easier, well, grammar, I'm great at it, to just throw it into Foursquare and then have Foursquare make a push notification to an API gateway on my behalf and then update the location in DynamoDB. And then Lambda can pull from that. And of course, as you guys know, like the mother is not just one mother. It's basically any parental unit in your family or extended family or just in general. And they generate lots of requests. So we have to make sure that this little architecture that we've built can scale. So this is our code. It's in Python, which is a real language, unlike JavaScript. Although, I will say, white space as a delimiter was the worst decision anybody has ever made. So import OS, import Foursquare. We grab our access token. We go to Foursquare. We get our location. And that's kind of our get location thing. And then we can throw that into DynamoDB if we want. Then we handle the event. The event is very easy. We just call get location, and then we return the location. And the goal here is to make it really, really easy for my mom or whoever to find out where I am. So let's do another demo. I started all these other demos earlier. The reason I had to restart them is because my computer restarted, so I don't know if anybody joined after that. My computer, when I got here, was just like not on. We're going to call a number now. And I'm going to see if the audio still works here. Well, actually, before we call the number, let's curl an endpoint. So we can invoke this Lambda function pretty easily. So if we go into Lambda, what I want to do is say, where, Randall? And because this is so small, come on. How do I test this? Just test. That'll work. OK, and we got back this little JSON doc, which includes a timestamp. It has a location, and it has some other stuff. And we can look at the code for this here. It's really straightforward. Basically, nope, this is not the right code. Sorry. This is what happens when your computer restarts. Everything was so set up. I was so excited. I apologize. So basically, I just have this little kind of request router map, this event function map. So if I go into Alexa and ask where is Randall, if I go into Lex and ask where is Randall, if I go into the API gateway, I'll get a different response back. And I would not recommend using this in production, and I'll talk about why, hopefully before the end of this presentation. But I'm going to speak very quickly, and hopefully we can get through all of this. So we've just invoked it there. But what we also need to do is we need to be able to invoke it. This is where everything freezes again. God damn it. We need to be able to invoke it over an API gateway as well, because as we may know, we don't want to provide IAM credentials to our mother, because then she'll see all the things we're doing in our AWS account, and she'll just be like, I can't believe you're spending that much money. So what we do instead is we create an API, api.randman.com, and we create an endpoint where, and then we just hit that. And we get back our location, which is the exact tool for theater. And just to prove that this is working, I'm going to change my location to something else briefly. Where should I check into? What is the name of this theater? Is this the Topfer Theater or the... What is it called? That's not on here. Oh, Kleberg. Yeah, sorry, I was looking for Playberg. So we'll check into the Playberg Theater, and then we'll hit this again. And now we're in the Kleberg Theater. OK, that was easy. Not a great demonstration. But what you can do with AWS, you guys have all seen this before, right? Like, you've seen curling an endpoint, invoking a Lambda function. It's really straightforward. It's bullshit. Like, we do this all the time. This is a serverless conf. But what you may not have seen is going a little bit further. And maybe you've seen this before, too. So like, where are you? Oh, no, I lost my audio. Thanks. My bad. And we'll say listen.
Randall was last at ZOCH Kleberg Theater seconds ago.
OK, so that's very easy. Quick to write a Lambda function. You just add it as a trigger. You can do like the IAM policy with the event mapping and all this other stuff. You guys have all seen Alexa skills before, right? So I just put this on my mom's Alexa, and it's also in the store if you want to go and find out where the hell I am. So the next thing to do is to talk about Lex. So Lex is a chatbot system. And has anybody used Lex yet? Yes, yes, yes. For the purposes of any video audience, that was 100% of the audience. Lex has amazing adoption, and we're really excited about it. So the Lex roles are pretty interesting because I can immediately publish to Facebook, Twilio, and Slack, except I don't use Slack because my mom doesn't use Slack. So we're old school with IRC. The Twilio thing is actually pretty interesting because I gave a similar presentation to this, but with much more preparation and more, suit when I was in Korea. And I'd never done the Twilio integration before, and without any code changes to my existing function, I went in and I created the Twilio number and I created the channel and everything, and it just worked. And I was really surprised, and I was like, wow, I expected this to fail. I wish I'd done this on stage, where it would have been more dramatic. But anyway, let's message Randallbot 2. You're going to see all my Facebook messages. Hopefully there hasn't been anything too crazy. Where are you? And we get our response back. Randall was just last here. And I didn't write any code to integrate with Facebook. And if I needed to include cards and stuff and automated responses, Lex can do all of that for me. So I didn't have to specify that I needed to talk to Facebook. The next thing I can do is I can text a number. This is, again, going to be all my messages. This is going to be good. And I can say, where is Randall? And this is the Twilio side. And hopefully we'll get a response. Maybe we won't. I don't know. I was just there 3 minutes ago. So this is all the same function running. I just want to make that clear. Like, all of these different integration points were completely trivial for me to add. And the next thing I can do is show you Amazon Connect. Who is using Amazon Connect already? Nobody. OK, let's make a phone call. I don't have a, oh shit, let's use Skype. This is the problem with the iPhone 7, jeez. 1-844-872-9026.
Ask me where I am.
Where are you?
Randall was last at ZOCH Kleberg Theater 3 minutes ago. Thanks for calling.
Cool. So I do that with my mom all the time, except I have my own prompts that are set up in something that's not called the demo flow, and it's actually my voice, except for the part where it's not. So the part that's not is the location, but everything else is my voice. And this took me, like, I built this in like 2 minutes. And you can see it's like this little WYSIWYG thing. I don't know what the hell that's for. You can also specify it as JSON, and that's always fun. But the Lex model building API, all of these other things, they're all out in the SDK now. You can build whatever you want with them. And that's kind of the demo so far with this stuff. So we can go back to the presentation, and we can kind of think about what other stuff we can do. And when it comes to thinking about what other stuff we can do, this is sort of the architecture where you have all this stuff coming in. And, oh, and also on Twitter messages. So this is new. So this uses the Twitter webhooks API. So you can message JR Hunt. Ooh, here, I think I've got compose. We'll just do that. Hard-coded URLs for the win. So where are you? Randall is last. Yeah, it works with Twitter too. So I don't know if that's public yet or not, but there you go, announcement. So I asked this question on Twitter, and I was like, hey, what are you guys building that's not the normal, typical serverless application? Because you've heard about FINRA, all the things we talk about at reInvent all the time, and all the approved PR talking points that I should be using before I get fired today. And these are the responses that I got. So there's a health AI, which is particularly important for me right now, with Ali Picard, and he's building this Alexa-powered health AI that's incredibly powerful. Martin J. Thwaites just recently published, I don't know what he called it, but I'm calling it Lambda Logstash. And Lambda Logstash is essentially when Logstash becomes too slow or too cumbersome to run, you just switch into Lambda, and you just take those credentials, and this is on GitHub. You can go look at it. You just follow Martin J. Thwaites and find his GitHub profiles. It will take those things that appear in the S3 bucket, and it will immediately put them into Elasticsearch. So rather than paying to provision and maintain all of these different Logstash servers and pull them up and pull them down as necessary, he can just have everything done in Lambda. And it costs less, and it's more performant. So instead of having to wait an hour for some of his logs to be in Kibana, or in Elasticsearch, he can now view them within a minute of them being posted. And then we can process DNA segments in parallel. I'm not allowed to tell you who that is, but who processes DNA? Lots of people, I guess. But then you can run sandboxes for untrusted code. So Danisco has Dasnico has a bunch of students that he wanted to allow to run code kind of for learning Java or JavaScript or whatever other languages we support. And you can create a little sandbox for them to run their code in. Incident management, Seely Turgay, who I don't know how to pronounce that, had an incident management API that they created. And then CloudFormation custom resources, everybody's using this. So who has created a CloudFormation custom resource based on Lambda? Yeah? Has anybody tried to manage a Cognito pool using CloudFormation? It is non-trivial. So this guy made it a lot easier, the logic box. They built something that allows you to add users and admins and all these other things directly into Cognito as part of your CloudFormation script, which I think is pretty baller. And then you have like the elastic transcode replacement with just FFmpeg on S3 upload. And then there are a bunch of different helpful libraries. You guys have heard all about these. There's Serverless, that's for the JavaScript folks, and then it also does other things too. Zappa is one of my favorite libraries. So Zappa is made by this guy named Miserlu on GitHub, and it basically allows me to take an existing application that's Flask or Django or whatever, and then I do pip install Zappa, Zappa deploy, and it just works. I don't have to make any changes. So if you're a Python guy or girl, check out Zappa because it is pretty good. And then Chalice is also pretty good, but it's not as good as Zappa. We made Chalice. Amazon makes Chalice. And Zappa is maintained by the community, and I think it's better. So I'm not allowed to say that. But Apex is really good for running other things as well. It's another sort of like containerized framework. There's Claudia.js. And then we have Sam, which is a cute little squirrel you guys see all the time at our booth. And then we just recently launched on AWS Labs a new Java kind of serverless platform called com.aws.serverless. However long the enterprisey Java name needs to be. And then we have a bunch of different reference architectures in AWS Labs as well. So all of these things I would strongly recommend. There's also github.com/enable/awesome serverless has a list of all the different awesome serverless frameworks. And if you just Google awesome serverless, you'll get a bunch of those. And then there's the AWS serverless Java container, which is kind of a Docker container that allows you to mess around with stuff. I'm going to finish pretty early here, I think. Oh, no, I have my other demos that I just started, so we'll see if those work or not. So we can invoke Lambdas anytime, anywhere. So think about IoT frameworks. So we have the IoT framework, which will allow you to kind of lazily invoke a Lambda on behalf of some IoT object. That's an extremely powerful platform. The context that I most recently heard it in, which was a little strange, is like somebody creating an indoor farm. And they were using a Raspberry Pi to collect all this metrics and then post it over the MQTT IoT framework into Lambda, where it was being processed and generating a bunch of results. And then the other lesson is something that we do at Amazon all the time, which is work backwards. So I had a goal in mind. I wanted to automate telling my mother where the hell I was, and I didn't want to have to deal with having to like constantly update that manually. So I worked backwards from my goal to the code. I didn't start with the code and just start iterating willy-nilly. I looked at the things, the components that I had available to me as Lego pieces, and I started working backwards from that. And that working backwards philosophy will serve you extremely well in a serverless environment. And the reason I want to point that out is that a lot of people in the past have relied on waterfall or some other insane agile methodology. I'd like to propose that ignore all of that, start with the idea of working backwards. What is the goal? What is the business goal that you were trying to accomplish? And then work backwards from there with the components that you have available to you. And if you don't have one of those components, make it up or look on GitHub. So iterating and testing quickly, those are very important. So there's local stack from Atlassian, which will emulate and mock out all of the AWS services. Not all of them, but a ton of them. And local stack is based on Modo and also Placebo, which is based on, this is in the wrong order. It should be local stack, Modo, and then Placebo. So Modo is based on Placebo. Placebo is the easiest framework to start. It's made by Mitch Garnett, the same guy who made Bodo. It's the easiest framework to immediately start mocking out stuff. AWS calls. You can even record some of the AWS calls that are happening and then play them back if you're trying to test stuff out. And then Modo is a couple of layers and abstractions on top of that, and then local stack is just like full local AWS for us to pretend with. And then I always create a bunch of fake events in like S3 JSON and kinesis.json, and then I just invoke those on the local command line with my AWS Lambda invoke thing. And then don't be afraid to mix and match languages. Developers are a scarce commodity, and you don't want them to waste a lot of their time trying to learn a language they don't know. Like, as much as I shit on JavaScript, I actually think it's an okay language. It kills me every time I have to work with it because WAT. And there's like 3 people in the audience who got that joke. And being able to mix and match languages allows me to use, or my friends to use JavaScript where it makes sense because they're JavaScript wizards and I am not. And I can write my stuff in Python or Java, or what is the other one we support? C#. And then when it makes sense, make your functions idempotent. I've never been very good at that. I believe in side effects. So all the Haskell people are like all up in my shit. So reuse functions, but only reuse functions when it makes sense. And I'm going to talk a little bit about the architectures of reusing functions in a moment. And then take advantage of parallelism. Who's heard of PyRen? I think the person who made that is here. Anybody? Okay. So PyRen is a framework that allows you to take a Python function that you are running and then just say, run this in Lambda. So if you want 40 teraflops of compute capacity immediately available to you, use PyRen. If you want 60 terabits of throughput to S3, use PyRen. And this is an extremely, extremely powerful paradigm. And these kind of new parallel querying and just-in-time compute environments are going to transform the way that we build programs. If my phone needs to process 60 terabits of data in order to recognize, I don't know, some tricorder crazy stuff, like am I going to live past tomorrow, then it can do that just by like invoking a function that goes out to the cloud and sends me back the result. Because as humans, we don't actually care about the data that goes in to make the result. All we care about is the yes or no or degrees of freedom response about what's happening. So take advantage of the parallelism of the cloud to get powerful information back to your users. So I want to take a moment and just talk about some different architectures that you see from day to day. So we have the simple architecture, which is one of the first things that I showed. That was the curling the endpoint. That was API gateway to the Lambda function. You can also have API gateway to various individual Lambda functions. And also part of this platform is the ability to use the proxy service. So like I said earlier with Zappa and Chalice and all these other frameworks, you just create a proxy function that is essentially your WSGI container or your Tomcat or whatever environment as one Lambda function, and it gets invoked on every single request. And there are advantages and disadvantages to all of these. There's also AWS Step Functions. Step Functions, unfortunately, cannot currently return, so it doesn't work in the request response model, but if you just need to kick something off, if you just need to start some asynchronous task and then you're going to pull it again later, step function is a very powerful way to do kind of this request router thing in the next page. So request router is when you have one Lambda that's responsible for dictating where all of the other data goes, and then you can invoke things asynchronously or request response model as necessary. And there's a little bit of increased latency here, but it's pretty powerful because increased latency doesn't matter for most humans when the latency is on the order of 10 milliseconds. And then you have this multi-source one. The multi-source one is what I showed you today with that where function, but I don't recommend you run with this in production. So the problem with multi-source is monitoring you're conflating microservices. If you have a microservice is not something like authentication. Authentication is a macro service. Login is a microservice. Logout is another microservice that's part of authentication. And you need to start thinking about monitoring and provisioning these things as individual endpoints and individual microservices. And that's going to allow you to have a much better production environment. And it's also going to allow you, while it may complicate deployment slightly, it will aid a lot of the debugging process. And to demonstrate some of that, I want to show you guys this thing called AWS X-Ray. It is hot in here. So while I've been talking, I've been analyzing these hundreds and hundreds and thousands of selfies, so we'll just make sure they're all in here. Afro hairstyle, cool. How is that like 90% accurate? I really want to know what this picture is. This could be very bad. It's just me. I guess it looks like I have an afro in that picture. That's pretty cool. I had no idea what that was going to be. Sorry. I'm glad it wasn't. So we have a human. We have curtains. We can detect. It used to say airplane. Afro hairstyle again. It must be late at night when my hair is like in this weird place. Electronics, human, and I can detect other stuff too. But all of this stuff has been inserted. But I want to see like how this performed. So earlier today, when I provisioned not enough write capacity units on my DynamoDB table, I kept getting throttled, and my function times were like going really, really high, and I was trying to figure out what was going on. So then I went over to X-Ray that I had instrumented, and this is what I got. So, oh, people have been trying to log into Twitter, trying to log into Twitch. That's pretty funny. Cool. So I've invoked this where Randall function a bunch of times, but I've also, in this kind of Lambda function that goes out and talks to recognition, experience some latency, and then this DynamoDB table. I haven't experienced any latency now because it's only been the past 30 minutes, but if I go back to the service map and I change it to like the last, I don't know, 3 hours, that should show, yeah, so you can see this purple part. I was experiencing a lot of latency and a lot of throttling there, so let's investigate it. And I'm not going to pull up a specific one because I only have 1 minute left, but I can go in and I can actually see what is going on here. So I made one attempt. I had a dwell time of 798 milliseconds before it was invoked. And then I had attempt number 1, and attempt number 1 did not work. There was an error. And I can go and I can see what that error was. I can't. But if I had better monitoring and exceptions and logging, I would be able to. And then the subsequent response worked. So I can go and I can see, OK, I'm in pending. OK, now I'm in detect labels on recognition. That took 1.1 seconds. Now I'm getting the response from recognition. That took 426 milliseconds. I'm posting to DynamoDB. That took 26 seconds. And the reason that took so long is that I was being throttled because I didn't have enough write capacity units on my DynamoDB table. So then I went in and I updated it, and I added more write capacity units, and everything started going faster. So if I go back to the service map and I look on the green part, and I go, well, we have filter stuff. I only have 49 seconds left, so I'm going to try and be real quick about all this. That's pretty much everything. Check out Amazon X-Ray. Where's the thing? And we'll play from this current slide. Also, if you would prefer not to see me on stage ever again, you can shoot me an email or a tweet. I'm happy to never show up again. I'm much more comfortable coding in my basement. Being on stage makes me very nervous. But we spend a lot of time on Twitch live coding. So I'm there most Tuesdays and Thursdays from like 2 p.m. to 4 p.m. West Coast time. And I'm almost always there. Sometimes Werner drops in and scares the ever-living Christ out of me. And we have a bunch of guests. And if you would like to be on the show, I'd also love to hear about it because I love live coding with people. I love pairing with people. And I think it's how all of us learn. The best thing that ever happened to me was when some guy tweeted at me and he's like, my daughter was watching you program and she feels so much better about it because she knows now that professional programmers make mistakes too. And it honestly made me feel so good because if you think about what we do every day, we make mistakes, we debug all the time. We're never actually getting stuff right the first time, and when we do, it's a rare occurrence. So I think Twitch and live coding has a future, and I want to be a part of that. But I wanted to thank you guys all for coming today. I have had a fantastic time. Please follow me on Twitter for more like serverless hot takes. And then if you want, I would strongly recommend going to Tim Wagner's keynote, which is going to be right now. I'm like going to put on my backpack and my enterprise-y suit, and I'm going to walk over there. I promise you this keynote is going to be amazing, and you're going to really like it. So thank you so much for your time and listening.